bothers me constantly. Referring to the dog. Alright, last part. Last 10 questions. You have a tennis ball today. I'm not going to throw it to you. I got to work on an equation. 2x plus 2 equals negative 52. So I'm going to write it down here so I have some room to work. Yeah, I'll write it right there. Because there might not be enough space to do my work here. Or if I already tried doing work here and then it's not there. So I want to get x by itself. So I need to get rid of times 2. I need to get rid of plus 2. You always start with getting rid of addition and subtraction first. So to get rid of plus 2, I need to subtract 2. Do that to both sides. Okay. Perfect line. 2 minus 2 cancels out. This is the part where I think a lot of us made the mistake. Negative 52 minus 2 more. Same sign, add and keep. Negative 52 minus 2 more is negative 54. Not negative 50, not positive 50, negative 54. Bring our 2x down. So 2x equals negative 54. So then you get rid of times 2. The opposite is to divide by 2. 54 divided by 2 is 27. And a negative divided by a positive, different signs, ends up being negative. So when we bubble that in, the lines aren't so good today, but here's our grid right here. On the far side, there's two bubbles, one that says plus, one that says minus. Excuse me, it's very important. If your answer is negative, you got to bubble in the negative. And then there's a decimal somewhere, so we would have had to put 2 and then 7. Okay? So if it's a whole number or an integer, if you don't see a decimal, you can put it at the end. That way you can match it up on the answer sheet. If it's negative, got to bubble in negative. If it's positive, this one's optional. So you can bubble it, you don't have to. Alright, 32. Two parallelograms are similar. As soon as you see similar and you see two shapes, that's a proportion problem. Okay, so we have our two shapes, so we give them names. I'm going to call this one baby because it's tiny, and I'm going to call this one mama because it's bigger than the baby. And then that's my key. So I put baby on top. Yeah, that's right, baby mama. Here's my proportion, two equivalent ratios. So now all I have to do is I pick a side from the baby shape. I'm going to say 12. And I'm going to find what does that correspond to in our big shape, which is 30. Okay. Then I pick another side from the baby shape, which is 16. And then I realize, and actually look what the question said. It says, what's the length of segment PQ? Oh, that's this length here, which happens to correspond to 16. Since I don't know what it is, I'm going to call it X. That's a good number for numbers I don't know. Solve proportion. We cross multiply and then divide. We could actually simplify this, which would have made this easier, but whatever, we're here. Let's multiply numbers. So 30 times 16. So I'm going to bring down my 0. So in my tens place, 3 times 6 is 18. 3 times 1 plus 3 is 4. So that's 480. I'm going to divide that by the number I didn't just multiply. And this will come out nice and easy. 12 can't go into 4, but it goes into 48 4 times, because 12 times 4 is exactly 48. I have nothing left to divide, so I'm going to bring my decimal up, and in this empty place, I'm going to put a 0. That gives me 40, which is our answer. We can check to see if that makes sense. If I think about it, 16 is bigger than 12, 40 is bigger than 30. If I simplify both of these, 30 over 40 is 3 over 4, and 12 out of 16, if I divide both sides by 4, is also 3 out of 4. Look at that. So our shapes are similar, their sides are proportional. Piece of cake. Alright, 13. Price of a TV was reduced from $250 to $200. By what percentage was the price reduced? Okay. So again, anytime you see a percent problem, again, you can think, well, this is a proportion. and every percent proportion looks like some part compared to some whole thing. Okay, so the part we care about, is what the question asks us, is how much was the price reduced by? So I'm going to say my part is the reduction. Excuse me. So the whole thing is what this is based off of. So how much the price is reduced is based off of what the price originally was. So my whole is going to be original. And we can also call this the generic one here is change over original because we're looking for percent of change. So first thing we got to do before we can set up our proportion here is we need to know what did the price actually change by. So it went from $250 to $200. So that's a difference of $50. So if I'm writing my proportion, if I want to put dollars on one side and percents on the other, my dollar change was 50, and then the original amount, it started at 250. Okay, over here, the percent reduction is what we're solving for, so that gets to be X. And then the whole percent every single time. The reason why proportions work so well with percents is because one of the numbers is always 100. Okay, there we go. So again, we can cross multiply and divide here. And this one I'm going to simplify because 50 over 250, well that's, take the zeros away, that's 5 over 25. I could simplify that even more, but why not? Let's just multiply from here because 100 times 5 is easy. $500 bills is $500. Imagine that. And then I'm going to divide that by 25, which is not too bad either. Because 25 can't go into 5, it goes into 50 2 times. And this is almost just like the last problem, the way it works out kind of nicely. We're out of numbers again, so can we add a decimal? Fill in our empty place. So X is 20, so 20%, which represents the percent reduction. Okay. So a couple things you just have to be careful of. One, I think some people, they'll do this step, they'll get 50, right? And they'll see 50% and they'll say, oh, I should pick this one. We need to remember that this isn't 50%, this is $50. Dollars and percents, totally different things. Okay? Remember that. Dollars, percents, different things. Alright, 34, some people actually did really well on, which is good. So bucket of golf balls, table shows the colors of each. Which of the statements is true if he picks one at random? So we just have to go through and check our answers. So golf ball is more likely to be green than all other colors combined. So if we look at it, we see green is the most popular, right? It has the most. But when we say all other colors combined, for that to be true, all of these, when we add them up, would have to be less than 18, right? Because we would need to have more greens than all of these put together. So if we say what is 4 plus 11 plus 8? So this is 15 plus 3. This is 23 non-green golf balls. Right, combination pink, white, orange. And since 23 is more than 18, it's more likely to get one not green than green. So this is wrong. G says golf ball is equally likely to be any of these colors. Well, if you look at them, it's a different amount of each. So there's no way you can have the same chance of picking all of them. Because we just said green would be most likely because it has the most of any one color. Alright, H, golf ball is 2 times as likely to be orange as pink. So 2 times as likely means we'd have to have twice as many orange as pink. So let's look what we got. We have 8 orange. It's not a great star. Now it's a circle. And 4 pink. So is 8 twice as much as 4? Well, 4 times 2 is 8. Look at that. So is this true? Yes. And let's check J just to be thorough. So golf ball is 7 times as likely to be green it is to be white. So here's green, Here's white. So this time we'd have to say, is 11 times 7 equal to 18? And it's not even close. So they're hoping that you would confuse 7 times as likely with there's 7, just 7 more green. It's like 18 minus 11 would make that. Would give you 7, but that's not 7 times. That's 7 difference. The answer is H. Almost there. Okay, Anna drew a map, Panama Canal. Good for her. And scale. Anna drew or used the map, 4 centimeters, 20 kilometers. Actual length is 82 kilometers. What's the length in centimeters of the map? Okay, so a couple keywords here. Map. Where did it go? Scale. There it is. Anytime you see scale and map on a math test, this is a proportion question. Absolutely. So we just got to look, what are we comparing? So I just want to look at the numbers. So I see 4 centimeters, 20 kilometers. So I'm going to say I'm comparing centimeters to kilometers. I'm going to call that my key. Then I can look, what else are we comparing? So 4 centimeters is just on the map, right? Compared to the actual. And this is going to be the basis of the proportion we're going to write here. So now we're just filling in numbers. How many centimeters on the map? Well, it says on the map 4 centimeters is 20 kilometers. And then the actual thing, 82 kilometers. So kilometers on the bottom. So there it goes. So we want to know what's the length, or what is the length in centimeters? Did I just mess this up? Hold on. Okay, hold on. I missed a word here. I don't really want map here. That's not accurate. I want to put the scale. Sorry. Misquoted myself or something? I don't know. We're looking for how many actual centimeters. I don't know. I don't like this key anymore. I'm not happy with it. But we set it up right. Centimeters, kilometers. That's the important part. We got centimeters on top, kilometers, kilometers, whatever you want to call it on the bottom. Here we go. Let's do math. That's what I'm good at. Words not so much. So we got 4 times 82 divided by 20. Ugh, terrible. Taking next week off. Bank on it. Alright, 82 times 4. This is 8. 4 times 8, 32. And then I'm going to divide that by the number I didn't just multiply, which is 20. Okay. 20 can't go into 3. It'll go into 32 one time. Give me 20. This is 8. Whoa, man. Oh my goodness. I need to take a nap because I'm making mistakes here. Sorry. 32 minus 20 is 12. Silly me. Okay. There we go. Back on course. 20 goes into 128 6 times. 6 times 20 is 120. Right? 128 minus 120 is 8. That's the 8 I wanted. I'm going to add a decimal because I still got some work to do here. Right? Nice. Almost finished. 20 goes into 80. 4 times exactly. Ran out of numbers to divide. So we're left with 16.4 centimeters. And that's the answer that we wanted. Okay. How do I want to put this? This is the actual river, right? 4 inches on the map, 82 kilometers actual. So 4, I guess scale works, whatever. Right, we figured it. Okay, 36. Let's talk about hot dogs and water. I think I could use some water right now. Not so much hot dogs. So a bottle of water for $2. Also bought some hot dogs, $2 each. Did not spend more than $14 on the hot dogs and the bottle of water. Which inequality can we use to find H number of hot dogs Jeff could have bought? Okay, so let's just write our own inequality here. So he's buying things. So he's buying one thing, buying another thing. So we know we're adding. He only bought 1 bottle of water. So there's no variable here. It's just going to be plus 2. and then $3 each. So that's what we're going to have to multiply by the number of hot dogs. So 3 times however many hot dogs you bought. Okay, so that's the left side. So 3h plus 2. Look at this, we're already halfway there. It's not any of these. On the other side is 14. It's only one option. So it says that's how much money did not spend more than. So we need to figure out what symbol is going to have to go here. So what needs to be bigger or smaller, depending on how you think of it. So this is what he bought, and this is just cash that he has, right? So what he bought said was not more than $14. So this has to be less than. But it says when it says didn't spend more than 14. So he could have spent exactly 14. So we also get to put an equal sign here. So 3h plus 2 has to be less than or equal to $14, which looks like answer G. Okay? So inequalities, it's not so much math, it's just a whole lot of like reading it as carefully as you can and remembering that the alligator, my alligator, just ferociousness. It's got a couple feet. I think some of those feet are supposed to be back here. It's not the best alligator. But the alligator eats the bigger number. Alright. Okay, 37. So this is the point of the test where it's like, alright kids, you almost made it to the end. Nice and easy, home stretch. Oh wait, here's this problem, and it's terrible. It says 4 sections, 2 are congruent trapezoids, the other are congruent right triangles, and the sides are a bunch of mixed numbers. Which measurement is the best estimate of the area in square meters? There's a whole lot of things going on here. We could find the area of this trapezoid, and then say it's the same as that trapezoid, and then find the area of this triangle and say it's the same as that triangle, and then add all 4 of them together, and that just sounds like no fun, right? But hopefully you recognized, well, these 2 congruent trapezoids and 2 congruent right triangles happen to make one big triangle, right? So why can't we just find the area of this one big triangle? So let's do that. So base, or area of a triangle, is half the base times the height, right? And base and height have to meet at a right angle. We got this nice right angle here going all the way up to the top of the triangle. So our height gets to be 2. So all we need to know is what is this base length. Okay? So we know these 2 trapezoids are the same. So if this is 1 meter here, this has to be 1 meter as well. And then since the triangles, the little triangles are the same, if this is 1 3/4, then this is 1 3/4. And since I don't want to deal with mixed numbers, I know that 3/4, right? Those coins with George Washington on them, that's say 25 cents. So 3 of those is worth 75 cents. Get it? 3/4. So I can say 1 3/4 is 1.75. And then I'm going to put 1.75 over here. Okay. And then I'm going to add all these numbers up to get the full distance across. That's 1.75 plus 1.75 plus 1 plus 1. I'm throwing a couple decimals so I don't get lost along the way, because I have not been doing a great job today. So 5 and 5 is 10. 14 plus 1 is 15. Bring up the 1. So this is 5.5. So all the way across the base, 5.5. Okay. So we have 1/2 of 5.5 times 2. So I could take half of 5.5 and then multiply by 2, or I can skip around a little bit and say, what is 1/2 times 2? Which is nice because half of 2 is just 1, right? So 1/2 times 2 is 1, and then bring my 5.5 down. And that's so nice because 5, oh man, my 5s are bad today. All this is bad. This is a bad job. If this was me, I would give me a thumbs down. Real talk. What was I saying? Okay, this is nice because anything times 1 is itself, so 5.5 times 1 is just 5.5, which ends up being the area, which is the answer. Except it said estimate, so I need to round this. So 5.5, if I'm looking at my answer choices, is closest to 6. So that's crazy, right? Like this, if you'd done all these individual shapes and did all of that work, and then you got an answer, and even if you did it correct, wouldn't look correct because you have to round at the end. This is a horrible question. I don't like this question. I give this question a thumbs down too. Just thumbs down all over the place today. Okay, 3 more. 38. This one people actually did really poorly on. Probably because this one question takes up an entire page and it's like a mess. Like here's instructions for what the picture is going to be, and then here's a picture, and then here's instructions about what the statements are going to be, and here's some poorly formatted statements with Roman numerals on them, and then here's an explanation of the question, and then what's going on? Like, well, this is a math test, right? There's barely even numbers here. Okay, that's okay. It's okay. So we're almost finished. It's almost spring break. Deep breath. Number of pets shown. You're a pet. You're a bad pet. Don't look at me like that. For Miss Anderson and Miss Murphy's class. Alright. So which of the statements, oh, here are 3 statements. Which of them is true? So there's some words here. So like we have range, which we talked about earlier, which is the highest number minus the lowest number. And range isn't too bad to work out here because the lowest number on both of these is 0. So really we're just saying how far away from 0 is the biggest number. And this one kid in Miss Anderson's class has 8. So the range for Miss Anderson's class is 8. And then for Miss Murphy's, the highest number of pets is 6 here. So the range is 6. So is 6 greater than 8? No, it's not. So number 1 is not correct. That eliminates answer F. So it's down to 2 and 3. And if you use a little bit of logical reasoning here, you should have done it at the beginning. If you notice, only one of these has answer 2 or statement 2 in it, right? So if statement 2 is true, this has to be the answer, right? It doesn't even matter what 3 is because there's only one that had 2 in it. So let's hope 2 is correct. If it's not correct, then it's J. Ooh, we don't even have to look at the third statement. This is amazing. Logical reasoning. Okay, symmetric. Symmetrical means looks the same on the left and the right. So do these look the same on the left and the right? And the answer is no, not really. Not like at all. So we could make it look symmetric. If you're curious about what that looks like, let's say we added a kid with 2 pets, and then somehow you have some like sad kids who can't let go of their former pets, so they have like -1 and -2 pets, right? Which is weird, but whatever. And then one kid out here, it's like -8 pets. So now we see like there's the left side and there's the right side, and they're exactly the same on the both. We'd say that this right here, this is symmetric. But what we have, before we started adding sad statements, is we have it goes up and then it goes down. It's not balanced. Everything's on the left side. Okay, and it's the same thing over here. It's even worse here. It's up, up. Not symmetric. So this is not true, which eliminates this one. We said 1 wasn't true, so it's got to be J. Now let's just check it. So mode number of pets is equal to the mode for the other. So mode is the number that shows up most often. So what's the most common number of pets? Which would be the tallest part here, which is 1 pet for Miss Anderson's and 1 pet for Miss Murphy. So is it the same? Yes, it is. So the statement's true. So it's got to be J. Okay. Alright, number 9. Robert Shelf. 6 mystery, 5 science, 4 history, 3 adventures. He chooses one randomly. What's the probability he'll choose adventure? Okay. So when I was looking at this, a lot of people actually picked 1/3, which makes me think that like they saw adventure and they saw the number 3 and they only saw one answer had the number 3 in it, and they thought, oh well, maybe there's a star question which like tests my ability to match a word to somewhere else in the question and then match that number to somewhere else. Don't do that. This is bad. This is bad work. You can do better than that. Okay? Probability is a ratio. Favorable outcomes to possible outcomes. Okay? Every time. Anytime you see probability, you can write down favorable over possible. So favorable is what we want to have happen. And what we want is for him to pick an adventure book, of which there are 3. How many possible outcomes are there? Well, that's based off of how many books does he have to choose from. So he's got 6, 5, 4, and 3. So we add those up. That's 11, 15, 18 books. So we get 3 out of 18. That's where this 18 came from. And then we just have to simplify this correctly. So 3 and 18 are both multiples of 3, which means I can divide both these by 3. So 3 divided by 3 is 1. 18 divided by 3 is 6. Gives us an answer of 1/6. Got a little bit upset earlier. Just bums me out that we spent all year working and then some people just try to pick the easy answer. It's never the easy answer. You always gotta do some math. Not always a lot of math, but at least a little bit, right? Okay, 14. During migration, a butterfly can travel 30 miles in 1 hour. Which graph best represents the number of miles a butterfly can travel in X number of hours? Okay. So in a perfect world, our graph would measure hours and miles, and one of the points would say 1 hour, 30 miles. So I'm going to try and find this point on these graphs. Okay, so here we go. So answer F goes from 0 to 5, so 1 hour would be like right here. And is that at 30 miles? No, it's not. So I don't like this answer. I'm going to keep looking. Answer G, here's 1 hour. Okay, so I go up to the line, and it's at, look at this, 30 miles. That's what I wanted. I like this answer. I'm going to check the other ones, because I'm a good hard worker. H says 30 hours. 30. People pick this answer. Why do people pick this? 30 hours to go 5 miles. 1 hour is like right here, and 30 would be, but this isn't even close. That's a bad answer. Please don't pick that answer. And the last one, this one, check your reading. This one says 30 hours for 1 mile. If you think about that, try to think about what kind of animal would take 30 hours. That's 1 day and 1/4 of the next day to go 1 mile. That's pretty slow. That's not butterfly speed. I didn't know how fast butterflies went until right now, but apparently it's 30 miles an hour, which is not 1 mile in 30 hours. So check your scales before you pick your answer. So our answer is definitely G. And with that, we did it. So to make sure we made it this far, we're going to draw a super cool looking butterfly. I don't know what butterflies look like. I think is slightly apparent here. This one got caught in like a bug zapper or something. I'm going to give him some fun little antennae here. Yep. He's got some eyes. And it's like, yay, it's over. I'm so smart now. At at the very beginning, in question 1, if you go back, there was a tiny little worm, right? And over the course of these 40 questions, it became a butterfly that knows how to do 7th grade math. Alright, that's it. Good night.